Good morning, students. In today's class, we are going to discuss about the Navy base classifier implementation. So we are going to implement here a classifier, and we are trying to classify the data using Navy base classifier. So here we are using a data set which is called wine recognition data set, and this data set we have taken from UCI machine learning repository. And this is a collection of data. UCI machine learning repository is nothing but it's a collection of database which consists of data related to the machine learning community. Okay, and it is generally it is actually hosted by the University of California, and this particular repository is used for machine learning research and experimentation. So we can use the data set from this particular repository for our work. So we are trying to load the data set from that particular repository. So first of all, I would like to tell you about the data set, that what exactly the data set is, and then we will discuss that how we are going to implement Navy based classifier on this particular data set. So we are applying the Navy based classifier on the wine data set, and we are trying to predict the class of wine based on the chemical property which is present in the wine. And this wine data set typically used in machine learning in the wine data set, which I told you already that UCI machine learning repository we are having from there. And this particular data set is consisting of chemical analysis of wines which are grown in the same region of Italy but derived from three different cultivars. And particular data set is consisting of around 13 features is this data set is consisting, which we can see here. This data set is consisting of alcohol, malic acid, ash, and all these features. This data set is consisting. And this data set is divided into three class 1, class 2, and class 3. Okay, three classes are there, and these classes are divided. Each class is corresponding to a specific type of wine, which is produced by a particular grape variety grown in the same region of Italy. Okay, so our ultimate goal is we are trying to do the classification task and trying to predict which cultivar is a given wine sample belongs to the based on its chemical properties. So this is all about my data set. So now first of all, what I have to do here. So whenever we are implementing any classifier, first of all, I have to load the data set. Then I have to apply pre-processing if it is required. Then I have to split the data into training and testing. Then I'll train my model and then I'll predict, and I can evaluate the performance of the model using precision recall and F1 score. Okay, so these are the steps which we need to follow. So first of all, we are importing the libraries which are required for us. So we imported NumPy and Panda, and from sklearn we have imported dataset because we are importing the dataset from the UCI repository. So we have imported all the required libraries. Now we have imported the data set from our UCI ML library, and we have taken that particular data set. Now just I want to see that how many features are available in my data set. So I'm using print, and I want to print the features which are present in my feature name. Okay, so we are printing the feature, and I want to print the label of the target also. So what is the label for my class? So I discussed already, we have an input feature and we'll have a target variable. So input feature, we are giving the input feature and we are trying to predict the target or a class of those input features. So just I want to print the features as well as the target label also. So you can see these are my features. So there are 13 features are available, and class labels are class 0, class 1, and class 2. So these are my label of the class. Now I've seen this data, this particular data set which is available in UCI repository. Now I want to take this as a data frame. So as we know that for that we are using pandas. So we are using pandas dot data frame, and I'm reading the data, one data, and I'm keeping in a variable X. So the data I read and I kept in a variable X, and now I want to print the first five values of my data set. So you can see here, this is representing the first five values which are present in the data set. At the same time, if you want to print the shape of your data set, you can write print wine data dot shape. So it will give the shape of your data set. Fine. And if you want to print the label of your classes, so I want to print the label of the classes. So class label is class 0, class 1, class 2. So I want to print the class label. So just simply will write y equal to print wine dot target, it will give the label of my classes. So if I'm printing the shape of my data, so shape of my data is what? This is my shape of data. So it consisting of 178 rows and 13 columns, because every column is representing one of the feature. And when I'm executing this particular line of code, it is giving me the answer, which is the number of classes. So class 0 is representing class 0, 1 is representing, 0 is representing class 0, 1 is representing class 1, and 2 is representing class 2. So this is class 1. Fine. Now, after seeing the data, I have imported the data from the UCI repository, and I have checked that what exactly how my data set looks like. Now, what the next step? The next step is I have to split the data into training and testing, how we have done for the other model also. So I'm doing the splitting. So from the sklearn, I'm importing train test split. So I imported the train test split, and I'm splitting my data into training as well as in the testing. So I'm using xtrain and ytrain for training data, and xtest and ytest for the test data. So we have used this, and I have split my data. Data set is what? Wine.data, which is containing the input data, and wine.target, which is containing the label of the data. And 30% data I'm taking for testing, and remaining 70% data I'm using for training, and I set random state value equal to 1. So in that way, we have splitted my data into training as well as testing. Now I have to build a model. I have to build a model, and I have to train my model. For that, I'm importing Gaussian Navy Bayse model. Importing here. So to import Gaussian Navy model, I'm using this command. From sklearn, I'm importing Gaussian Navy Bayse classifier. Okay, and I'm creating a Gaussian Navy Bayse classifier. Just I have to call this function, and I'm storing in this particular variable. Now I have to train the model using my training data. So where is my training data? My training data is available in train, xtrain and ytrain. Xtrain is representing the features, and ytrain is representing the label of those features. So I have written here xtrain, comma, ytrain, and I'm fitting my model. Okay, so I fit the model. It means I have trained the model. Now, after the training, I have to check that how my model is performing. So for that, I have to do the testing on the test data. Okay, I have to do the prediction of the test data. So I'm using here Gaussian Navy Bayes classifier dot predict, and I'm using here test data, and I'm predicting the result. I'm storing the result in y underscore predict, and the results I want to print. So these are my results. So the first data point, it is considering it as belongs to class 2. Second data point, it is considering it belongs to class 1. So like that, it's giving me the output. Now what actually I want to do here? Now I want to check the I want to evaluate the performance of my model. So to evaluate the performance of my model, we are using here we are calculating the accuracy. So to calculate the accuracy, we all know that what we need. We need the actual value and the predicted value. So to check the performance of the model, I'm just printing the accuracy. I'm printing the matrix dot accuracy score, and for what? For the actual data as well as the predicted data. Fine. So I check the model in the check the accuracy of the model. At the same time, I want to print the confusion matrix also. So if I want to print the confusion matrix, what I have to do? You can see here in the code, again I'm using the confusion matrix function, and in that I'm passing two parameters. I'm to print a confusion matrix between the actual value and the predicted value, and my confusion matrix will display the true positive, true negative, false positive, and the false negative, all value it will display. Now I want to do a better visualization of my results. For visualization means I want to print a graph or a confusion matrix for my results. So for that, we are using this particular line of code. So in this particular section, we are using a function which is called mlx10 plotting, and which is used for plotting the confusion matrix. And if I want to visualize the confusion matrix, I'm using this particular function. Fine. And at the same time, you can see here in this particular line of code, just I'm mentioning here that what would be the size of my figure and what would be the color of my figure. So here cmp cmap equal to plot.cm.green is representing that whatever arguments I'm specifying, those will be in the green color. Okay, and the size of the figure will be 6 of 6. The same way we have given the label, to the I want to give the label to my graph. So I am giving label which is prediction and x-axis, and font size will be 18. Same way y-axis I'm giving the label which is actual, and font size is 18. In the same way, I want to give the title of my graph which is confusion matrix, and font size will be 18. You can change as per the requirement. And finally, I want to display the graph. I want to show the graph. So when I will execute this, and when I calculated the accuracy, my accuracy is here 0.98. It means my model is performing well. The accuracy is around 98% here. And as it is a multi-class classification, it is having three classes: class 0, class 1, and class 2. So it is displaying confusion matrix in this way. So it's representing your true positive, true negative, and false positive. And we have written the code for visualization of the confusion matrix. We drawn the confusion matrix here. So this is your confusion matrix, and you can see here there are very less false prediction here. Okay, there are 23 samples which are predicted as true. Okay, true positive. There are 18 sample which are predicted as class 1, and there are 12 sample which are predicted as class 2. So there are very less prediction. This is the only prediction which is wrong. Okay, for class 1 there is only one prediction where it is predicted as class 0, but actually it was class 1. So there is only one wrong prediction happened here. Clear? Now this is all about your confusion matrix. Clear? The same way, if I want to work with the precision recall and F1 score, that also we can do here. Just we have to import the matrices from the sklearn, and have to print here matrix dot classification underscore report between the test state, between the predicted data as well as the actual data. So I'm using the same code here, and finally I'm getting the result, which is my precision recall and F1 score. So this is the final outcome. So I hope it is clear to you that how we can build a Navy-based classifier and how we can implement. So the basic step of any classifier is I have to import the data. Okay. I have to import the data. Then after importing the data, I have to do the pre-processing on that particular data set if it is required. Once the pre-processing has been done, we have to split the data into training and testing. And after that, you can train the model, and finally you can test your model. And if you want to check the performance of your model, you can use different evaluation parameters like accuracy, precision, recall, and F1 score. Thank you.